Hey everybody, welcome to TCP Talks with Jonathan Baker and Justin Brodley from the Cloud Pod. In this series, we're bringing you interviews with the best and brightest leaders and heroes from the tech and cloud industry.
Fantastic guest for us today with Mark Curphey from OpenRaven. Mark, you want to introduce yourself?
Yeah, I'll kind of give you my background and then kind of how we came to start the company because it's all kind of related. So English originally was a cryptographer out of a place called Royal Holloway in the UK, and then worked for a whole variety of software security companies. So ISS, a network security startup, ran software security at Charles Schwab, and then spent the time at Microsoft, both running a security tools team and then a thing called MSDN. And so sort of been involved in both sort of security for 20 odd years, mainly on the application security side. A good friend of mine, Dave Cole, Dave and I met way back when we were both at ISS and a lot younger. And Dave sort of went through a similar but parallel path, which was the early product guy at a company called CrowdStrike, sort of modern breed of malware companies, and then at Tenable. And Dave and I had always wanted to work together, and timing came. And so, essentially having both had some startup success, kind of went to the venture community, easy-ish to go raise money, and said, okay, well, we're going to go start a company. And so the obvious question then comes is what do you want to do? Both good capitalists, well, let's go tackle a problem that's meaningful and that you're going to be able to make money from. Then that has to be okay, well, what's the biggest security problem people are facing today? And so we very simply went out to all of our CISO friends, or chief security officer friends, and said, what's the biggest problem you've got today? And they would tell you, I'm dealing with identity, I'm dealing with patching, I'm dealing with malware, I'm dealing with phishing. They would just rattle off all of these things. But they would always come back to everyone is getting breached. The cloud has moved in incredibly fast. There's been all these political things where it used to be the security guys controlled the gateway to the data center. Well, guess what? A credit card controls the gateway to the data center now. Security's kind of been moved off to the side. And as a result, they don't know where their data is. Data breaches are happening constantly, and these are the big things that get companies in the press. And now with the regulatory environment, they're the big things that are causing the fines. So they said, it's a biggest problem we have and the weakest story I have around tackling it. If you could go solve that, we'll buy whatever you're going to build. So of course, then that, great, that's the problem we'll go solve. What OpenRaven does is ultimately kind of at the top level is help you prevent data breaches. What that boils down to is, first thing is figure out where is your data, then figure out what type of data you have, then figure out how that data is currently being protected or who has access to it, and then figure out how to protect it. So it's really that simple is the kind of journey we're on. And the first piece of that we've solved is where is your data? We're now just released the first product around what type of data do you have and how is it being protected? And then sort of down the road, we'll figure out how to just continue to increase on those features.
Interesting. So when you think about the data classification problem, the data breach problem, how does OpenRaven approach that challenge to even begin with? And there's a lot of solutions that are out there in the market. Macy, for example, from AWS. Google has their DLP solutions. Mm-hmm. How does your approach differ from what they're doing?
So the first thing, we can get into the details about Macy. You did a webinar. Ultimately, the problem is not just classify a piece of data, right? No one knows where their data is. So if you think about this big data ecosystem, right, we've got people are ETLing data everywhere. You've got buckets that replicate data from one place to another. You've got people that are using buckets just as staging to go do later analysis on it. It's not so the first problem is no one knows where their data is. It could be on file systems. You've got people like Oracle support who tell developers to go drop all the tables and dump them in a bucket and make it available for everyone. You've got developers who take a copy of production data and put it into a testing VPC. The second thing you've got is the data classification thing. And what we heard consistently from everyone, and this is still true and kind of gets to the Macy thing, is, the state of the art for that is a regex. Reality? Come on. That's like saying instead of using Terraform, we're going to use Perl scripts, right, to configure the cloud. That's basically the way that is, which is clearly ridiculous. Google's DLP was really focused around binary analysis, and it's very good. Was focused around that. Macy was originally a project called Harvest.io, which came out of a CIA funding program called Incutel, which, whilst great and decent, every single customer that we spoke to in the early stages said, A, it doesn't work, B, it's ridiculously expensive, and 3, it's only on S3 buckets. Well, whilst the register is always reporting breaches in S3 buckets, like my customer data is an RDS. like that's a piece of the problem for me, right? So like, sure, it's popular, but I shouldn't be thinking about trying to protect myself from getting on the register. I should be thinking about like, where's the most important data and how do I protect that? So it's the current things were like, thin slices of solving the problem. It's not about thinking about what the end-to-end problem is. Where is my data? What type of data do I have? How's it protected? Who's got access to it? And how can I provide automated controls to put that in place?
In terms of regulated industries, lots of sensitive data, whether it's healthcare or financial or any other kind of personal information. How does OpenRaven go about scanning that in a secure way? Mm-hmm. What's the flow like?
Yeah. So first thing we do is basically go out and run discovery in AWS, right? So basically you connect to an AWS org, ideally connect to a single account, and essentially pull all that info back. Underneath the hood, basically we pull it back into a set of documents, put it into a document store, and generate a graph on top of the document store. So basically what that enables you to do is like, you got all the account info. You can tell the peering relationships, right? You can tell all the attributes on the assets, right? So essentially you build it into a queryable system. So that becomes important around the flow piece, which you mentioned, Jonathan, because there used to be a privacy law that was originally called Safe Harbor. It was then changed to be called Privacy Shield, and then it was thrown down by the EU. And basically what that did is it described how you had to protect and handle data from European data subjects, European citizens. When that was thrown down, the effectiveness said, basically, you have to now know who you partner with and where your data goes and how you handle it. So as a result, no one knows, hey, I've got this connection out here from this AWS account to this partner. Do we have a legal contract in place and how it does? What we've been able to do is kind of go, okay, great. Look, you've got a peering relationship here, or you've got an exit here. You've got a security group here, which gives, access to this IP address. That means that partner, how have you handled that? And what does that thing have access to? So, and we do that in a 3D map, which is kind of super interesting. It's kind of like, if you've seen war games, it's like, great, I go click on this thing and the missiles appear. It's like, oh, I've got this thing. And it's amazingly interesting. Like one of our customers has said, like, oh my God, like some DevOps guys put a backdoor into the Redshift database there because he clearly doesn't want to come through the main gateway, right? It's like, oh, and that relationship there goes to these people. Like, so that kind of piece around the access. So we build that graph database, and then it allows you to go look across it. And with that, you can also then see, you've got all the IAM in there, you've got all of the, like I said, security groups, you've got all of the peering relationships, and you've got all the attributes about the assets. So you can kind of clearly say like, okay, show me all my buckets that are open to the world, or show me who has access to these buckets, etc. Then on top of that, then we do the classification. So the classification is fundamentally different from Macy, etc. in that what we do is we build it with a Lambda function. So you land the Lambda next to the data store. We did buckets first as well. We're doing RDS and other things now. So you land it next to the data store. And the reason why that makes it better is of course, you can, parallelize it, horizontally scale it, right? You don't have to deal with the data transfer problem that you have to do with other things. Like you have to move the data to someone else to go in and analyze it, etc. And you can scale it up or scale it down based on the size of the data you want to do. The other thing that we realized fairly early on when you go talk to people that have tried Macy and other things is that because they're essentially a regex, like you just wind up with mass problems. So to give you the canonical example, which actually one of our customers found is like, great, I go find an AWS key, right? Well, you know what the format of that thing looks like. It's like something else, right? So what we've done is we've built these validator functions. So what they basically do is I can pass it an AWS key. It'll try and log into AWS and it'll go, oh yeah, this is the key for this account and it's real. Or, oh, it just matches the string format. Because we had loads of people that just spent their time chasing down buckets with something that looked like a credit card or something that looked like something else. And the fundamental difference is like, is this a data type or is it real data? And you have to answer two questions, and that's kind of really what data classification is.
Macy is always funny to me too because you go to test it, and so you create a text file with something that looks like a credit card or something that looks like a social security number, and you go put it in the bucket, and then Macy would never see it. And then you'd open a case with Amazon, and they'd be like, "Oh, well, you don't have enough credit cards or enough of those in your file," which was so silly. I'm like, "Well, but that's not the point. I need to know that this file had it. If there's one of them or there's 1,000 of them, it just never really made a lot of sense."
Yeah. I mean, look, in their defense, it's an incredibly hard problem, right? And it's not trivial in any sense. I know the guys who built Harvest, and they're incredibly smart. And I uploaded 10 megs of credit cards. It found 3 first names, which was ridiculous. We have a streaming company who spent $1.5 million and it found something ridiculous, and they asked for the money back. I mean, So there's no shortage of stories around it. The part of the challenge is that, as you guys know, data it's not one thing, right? Like how I store a credit card, I may have a CCV number, I may have a name, I may have an address, I may have the card number. There's all sorts of different parameters of it. And the data could be stored in multiple different ways. So you have these things of like data adjacency, like, does it have a CCV number, an expiry date, a name associated to it, a card number? That might be something which is real. With Macy, even if you just use the straight matching techniques, you don't have control over the adjacency thing. So that's why a lot of the basic trivial cases, like I just uploaded 3 credit cards, miss. So in the webcast we did last week, we created literally a CSV file and dumped about a whole bunch of credit card numbers, SSNs, and it completely misses it. Like I know how to structure the data to get it to match it. But guess what? The bad guys also know how to structure the data to get it to miss it, right? Like pretty easy, right? So it's a hard problem to solve.
Yeah, and I think also your comment about S3 and everyone's focusing on S3 and public buckets as the big exploitation, but what's in your RDS database is just as important. What's in your EBS volumes is just as important. Mm-hmm. And it's good to see that it's a different approach. It's a different model, and by using Lambda, you're able to kind of access any of the data stores that Amazon wants to build in the future as well, which is hugely valuable.
And not just the ones Amazon build, right? Elasticsearch is equally as thing. MongoDB, right? Equally. So Elastic is just as thing. And like, people building up these Elk stacks and dumping all their logs into these Elk stacks, like that's where a whole treasure trove of this stuff is. So yeah, exactly. That's the point. It's like data is everywhere. It's not an S3 problem, despite kind of what you may read. That's the majority of the headlines, but it's data is everywhere, and that's how you got to architect a solution to solve for that, for sure.
I read recently that Open Elasticsearch clusters is the leading cause of data loss today.
Mm-hmm. Yeah. I mean, look, buckets are easy. It's like a file system. You just drop your stuff in there, right? But Elastic's typically indexing meaningful info by its very nature, right? So it's like, Mongo as well.
And it's so easy to search.
yeah, it's beautiful, right? It's beautiful.
There was that white hat hacker not that long ago who was actually finding all the public Elasticsearch instances on the internet and was deleting all the data, which I found was hilarious. I was like, that's the best hacker ever. I want that guy.
I know there are underground search engines now being built that will index buckets, index Elastic and stuff. But I mean, people have always done that. There's this thing called ZMap, which is originally this like network scanner to figure out ports open. And you get. I mean, again, it's like the irony, isn't it, that you can introspectively use the cloud to go scan the cloud. It's like we're living in a new world. It's great.
So once you've discovered the data and classified the data, what next? Like how does that help me protect my customers?
So we use OPA. Open Policy Agent. So basically, we've written a DSL that sits on top of OPA that allows you to specify a set of helpers. So you can do things like say, I don't want to ever have data from a European subject who's maybe less than the age of 14 stored in the North America region, because then I've got a GDPR problem, right? You can't store that, or it's not protected. So we ship with out-of-the-box data classes. So all of the normal things you see in Macy, but also, not just AWS keys, like Twilio keys, Stripe keys, all of those types of things, all the healthcare HIPAA type info, all the personal data info as well. And then you can basically write a policy that says, look, I don't want to ever have any sensitive data on anything that's not encrypted. So, PCI, I don't want to ever have credit cards that aren't on any device that's not encrypted, because that's a PCI violation and things. And then OPA will basically just put it into monitoring mode. So any change that happens, the OPA rule just runs. And so it's kind of like a predicate system, right? You just iterate across the graph until the predicate doesn't return correctly. And it's like, oh, I've got a violation. Like I've found an address. The address is based in Europe. I've also found an age. The age and the person is less than 14. And oh, by the way, that data is on this host in this region. Bam, now I've got a problem. Now I raise a violation. And so that then sends that as a violation. And what we've done is that's hooked up to EventBridge. So you can basically just push those violations out to us to a fire hose, and then people, typically the large customers, will suck those up and push them into either an event management system that they have for security or something else, some sort of alerting system so they can do it, or ultimately push a ticket out to a Jira or something like that through a webhook.
Do you also classify encrypted data?
If you're using KMS, you can grant us access to that so we can open it. With the client-side stuff, of course, we're in the same problem as everyone else. And then what we found originally, to be honest, we thought we would have to integrate with some of these old school key management systems that sort of fails and all that. and then figure out how to kind of go do that brokering. But pretty much everyone's either using KMS or they're not doing it. So as long as you grind us to KMS. I mean, again, our philosophy here is like AWS is a giant programmable operating system. Use the features of it in the same way that anyone's going to build on it. Use the same features to go analyze it, right? Versus trying to do something offline. So yeah.
It is an interesting challenge. It's good to see that you're saying most customers are using KMS or they're using the cloud HSM capabilities. From your standpoint of dealing with data security and these things, server side or application side encryption versus storage side encryption, where do you see the value prop in those two scenarios? And is there one thing that you think is more prevalent in cloud from what your experience looks like?
So having come from the application security world, I frankly have made loads of mistakes in the past, which is like, you should separate segregation of duty. Like you should, you can't have the poacher and gamekeeper, and you shouldn't have operating system stuff. Don't use encryption built into Windows. Have something separate. My take now is, and maybe this is just because I've got older or whatever, is like you make it easy for the developer. There's more chance they'll do the right thing. And, 100% of the people doing an 80% solution is better than 20% of the people doing 100%. So I think that as long as, KMS is easily available, let's take the bucket thing as an example. Like you've got a couple of easy options, right? I can just default encrypt, or I can go use, the advanced encryption and figure out how to set my policy up. But just getting most people just to flip the bit and make sure that it's encrypted at rest, awesome. But the minute you start kind of requiring developers, if you kind of say, well, look, data at rest, it's like, great, here's all the data stores, RDS by default at rest, S3 buckets by default at rest, developer doesn't have to deal with anything. Awesome. You're just going to inherit the whole thing. So I think that my take is that's the better option by trying to do things complex. I mean, it's a hard thing, right? Like, look, I have a master's degree in cryptography. I wouldn't trust myself doing detailed crypto stuff these days. I wouldn't. It's freaking hard.
I've talked to many people who are trying to get out of very expensive HSM solutions, and like, we're going to roll our own encryption story, and I'm like, why would you do that? Please just go find something open source. Don't try to do it yourself.
When I was young, when I was first out of Royal Holloway, so I was like my mid-20s, I had the best job in the world. I spent 2 weeks traveling around Europe, literally with a secure briefcase, giving crypto keys out to set up a system for a bank in the UK. I mean, like, it's friggin' madness, right? Like, that doesn't scale these days, right? We're living in a distributed world, so yeah.
Dealing with all the crypto cards and all the things to unlock the HSM, because you have to have physical unlocking of these things, and you're like, how does that work in a cloud world? It doesn't. Reality of these things.
I mean, look at a good example of that, I think, is Let's Encrypt, right? Like, if you roll back like a couple of years, SSL certs were expiring left, right, and center. People had the wrong certs on the wrong host. And the problem was like, it's too hard and it cost me money. Like, now it's free with Let's Encrypt. Like, problem just goes away. Like, when was the last time you heard about it? You saw SSL problems, right? And so, like, raising the bar on classes of problems you can do at an infrastructure level. In that case, it was probably, the Linux Foundation providing a service to everyone. But if you can do it at an infrastructure level inside of a cloud operating system or whatever, then classes of problems go away and it just clears it. So I think from the KMS problem, like, that's a good class of that, where you abstract the complexity away, make it easy for people to use, and just raise the bar. Right?
I think traditionally data loss has been, the focus of data loss prevention has been at the edge of the network. Do you think that's had its day now?
So yeah, if we were on video, you'd see me smiling. Like, I'm not sure if it was at the edge; it was on the freaking endpoints, right? Like this was on laptops, but again, that's a different era, right? Like, someone sent this Word document over an email wrong. Like, when was the last time you saw a register article about a sensitive Word document? It wasn't. It's a customer database. So like we've moved on from that. Like, that was 20 years ago. Honestly, DLP has a bad smell in the security industry because it was all about email and tracking Word docs, whereas the breaches are based on customer databases or large data sets, and that stuff now sits in the cloud. So it's a fundamentally different thing, right? And then the edge thing, to your point, the security industry historically has been focused on network security because that's what it knew, right? It was firewalls, it was doing stuff at a network level. And so the old school security people kind of think about how you protect stuff. So like, as an example, when people started protecting applications, it was web application firewalls. Well, like on the network level, HTTP doesn't understand the context of what's happening inside of an application. Why would you expect it to be able to make the right decisions? It's kind of like the wrong thing. So that's why when we think about it, we think about like, look, if you're protecting data in the cloud, like you got to wire it into the cloud to understand which IAM has access to stuff, which routes, which security groups can give you access to stuff. Like, how's the object being accessed? Like, that's the only way to understand the context to protect it, right? You can't do it in some sort of edge device or something. It just doesn't make sense.
In the industry Justin and I are currently working in, I mean, we deal with financial information and personal information on a daily basis, and this is dealing with consumers. By the nature of the industry, we have to send information in emails to people, which include things like their address, their name, contact information, things which would typically be flagged by DLP as being, a no, don't send this, but we have to, because it's the business we're in, and so it's very difficult to implement a DLP solution at the edge, I think, which understands the context of, well, this email is allowed and this is okay because it's going to the person who the information is describing, but this other thing is not. So it's definitely a huge challenge.
I had a very funny story from one of the big well-known logistics shippers companies, and they were using a DLP product, and they were trying to check credit cards, and they literally had to shut the credit card stuff off because they found that someone in the mailroom was actually using her credit card to go send flowers to the CEO. And it was triggering all sorts of alerts. And it's like, and I empathize because it's a really hard problem, right? It really is, but it's like, yeah, I think you got to figure out protect the high value stuff, not protect the edge cases, which I think that stuff's become, right?
It's a problem of focusing on what's high visibility versus what's actually high impact.
Yeah, exactly.
I also think it's context awareness, right? It's understanding the business that the company is in, understanding what they're trying to send out and why they send it out, and then put that context to apply. It's okay that I'm sending one email to Jonathan with his personal information. It's not okay if I'm sending Jonathan thousands of different people's email addresses and addresses. And so that's typically where a lot of these tools kind of, start to break down a little bit, is around context. And so, I think that's what's really important, in the Open Raven story here, where you're doing data classification, you're understanding what the data is first. And then you guys can, address that metadata, make sure you understand, okay, that is a confidential data, that is a private information, understand what it is. And then you kind of pull in that Amazon perspective of, okay, like, well, who has access to that data through IAM? Who has access to that data through, this server EC2 class has this access to the RDS database, et cetera. I think that context is really what makes Open Raven really interesting.
When I was at Microsoft, vendors had a VDash username. So it was pretty easy to figure out if someone was a contractor or someone was an FTE. FTEs would sign the internal security policy, vendors wouldn't, right? And so you could make decisions based on things like that. And I think access control is complicated enough already, but you can get a long way with some of the relatively simple things. Should you ever have vendors that are in a customer VPC where you've got customer data? Maybe not. I don't know. But your business should be able to make that context decision, and then you should be able to enforce it, right? So that's why we kind of adopted OPA and wrote this DSL on top of it that allows someone to describe, here's how we want to run the business. Go tell me if there's a violation against that, rather than oh, here's what looks important, and then you figure it out. You know the context. You have all the knobs and dials in the cloud to go figure out how to get the two, and then compare the two and figure out where the anomalies are.
So speaking about business decisions, I want to ask you about the open side of Open Raven. In the past few years, people like MongoDB and Elasticsearch have shied away from the openness and have changed the licensing to prevent the likes of AWS or GCP from capitalizing on their technology. What made you decide to open source part of the product and provide an open core?
I've been long involved in open source. I was the guy who started the thing called OWASP, the Open Web Application Security Project, years ago, and have long sort of admired that model. Did some work at the Linux Foundation for Jim Zemlin, helping them figure out some of the security strategy stuff. And I fundamentally believe it's the right model for businesses, because it allows large companies to look at a sort of relatively small startup and say, well, there's sustainability there that we are building on top of open source code. So if we didn't do that, that would just be hypocritical, right? You can't just consume and expect it all to be there. The world would collapse. And then I think there's a lot of other kind of attributes that just make it the right thing to do. You tend to attract a really nice, a good set of people that want to work on tough problems and want to work collaboratively. So there's loads and loads of great things about it. Now, the flip side to that, like you said, is that there have been cases where that open source business model didn't work out for a bunch of people. And if you go back through Red Hat, it was all about selling support. Well, that worked great for Red Hat, hasn't worked out for a lot of other people. You look at companies like Sentry, who kind of originally just open sourced the entire code, and until they had to change their model because other people were more efficient at hosting than them, and the Mongo things and the Elastic things are all kind of there. So Dave and I were kind of committed to an open source model to start with, but what that open source model, we had to figure out what it was. When we released the first kind of community early beta release, we took a step back and said, well, oh my God, like, yeah, we're giving this away. And like this company who's like further down the road or done this other thing, they put those two things together, they get 3 and we can't put what they together. Like, oh my gosh, that's a problem. So we just pushed a couple of repos, kind of out there and said, like, let's take a pause back. We're backed by Kleiner Perkins, who are, obviously a big VC, and said, like, okay, how do we do this properly? Because that is not properly, but we need to do this properly. And they're committed to the open source model. They've got a bunch of great companies that have done it. And so we hired a guy called Dave Lester. Dave was involved in the open source programs at Twitter and at Apple, Foundation DB at Apple, and then all of the other stuff that came out of Twitter. And we're in the process of doing that now. So that open source version of the tool will come out a piece next year. The way we think about it is, if you go back to that kind of product, it's about discovery, then classification, and all the operationalization stuff. We're open sourcing the discovery piece. So that discovery piece itself has end-to-end value, i.e. go find out everything that I have in my cloud, allow me to go query it. But then what we do is build a set of value stuff that sits on top of it. So that way, you can't just, of course, open source a set of repos and, it's not a complete product and doesn't have end-to-end value, because that's just like shared source a piece of your product. So think of that open source, the thing that we're releasing there, as a better version of cartography or Cloud Mapper, if you know what those things are. And then on top of that, then we build these high value services, better version of Macy, all of those other things on top. So that's kind of where we are. But it's hard. That's why we had to take a pause back. And it wasn't obvious first of all, because you got to make sure you balance building a sustainable, scalable business and all of those other things, like doing there's no point in doing open source if you're not going to do it properly. Like, and a lot of companies don't do it; they kind of half-ass it.
Yeah, I think one of the concerns that I've heard over the years, when it comes to installing agents on operating systems, is, well, what can this tool do? I don't know what it does. I didn't write it. I don't know what it does. It probably has root privileges on the box to provide remote access or remote configuration or remote updates and things like this. So I think one of the values I see in the at least partially open core model is that I can look at the code and I can establish, at least a baseline of trust. I know what it's doing. I can see what you're writing and the quality of it and how it works.
And even if you don't do it, right, that vendor knows that someone could do it. And therefore, there's a much higher bar of the quality bar, right? That knowing that if that gets out, if you didn't do the right thing, you're going to get called on it. So it's kind of like being held accountable as well, I think. Yeah.
How do you think about engaging with the community for these this open source discovery? Like, how are you guys going to evangelize that? How are you guys going to go out to get people to contribute to this? Because it's an exciting project. I think it has a lot of opportunity, but open source lives and dies by that community.
Yeah, totally. And again, so not to put too much effort on Dave Lester. I hope he listens to this, but the Dave Lester show, right, comes in. But no, Dave's amazing, and he's been thinking a lot about this. So if you look at open source, like, you can't just drop a bunch of repos out there and think that you're going to build a community around it. Like, it doesn't happen like that. So what we're doing is we're actually looking at partnering with some cloud providers in some ways, and kind of go through all the details around that. But to make sure that this stuff scales, I mean, you got to make sure all the licensing is correct. Like, you can't have some crazy GPL license. It's got to be MIT and Apache so people can contribute and push in. You've got to accept that potential competitors can have access to it, and you should encourage them to participate as well, right? It's not a marketing extension. It's got to be a proper, genuine community. And so what we're doing right now is there's a set of people who have the requirement for that general discovery piece of it that want to work with us to go figure out how to do it. And so we aim to kind of release that around about the March time. And then basically what that'll look like is the ability to go discover AWS at scale, use our Kibana instance to go query it at scale, and extend it. And there's a good chance that will also include GCP and potentially one of the other cloud providers at that time as well. And then, there are people that are interested in doing things. So Rob mentioned agents. We got one company that's not a tech company, but uses a lot of technology that's interested in wiring OS Query into that graph, right? So like, I have all these nodes. We use OS Query for monitoring. Like, maybe I could kind of add that in, and then I get a better use case out of it. So for us, it's kind of like, if we can find those people to also participate in that community, to have a vested interest in doing it, we think that's an interesting way to do it.
One of the things that has bothered me about this type of tool in the past is the vendors have a very rigid view about what data should be protected and what shouldn't. It's financial, healthcare, PII. There are plenty of other types of businesses who have proprietary data or very valuable data If I'm collecting, self-driving car information, any kind of telemetry, any kind of data which I can make money on is potentially at risk of theft. So how can I use a tool like OpenRaven to protect my data, which you don't necessarily understand yet?
So the way we kind of view data analysis is there's a set of things. There's analyzing predefined things. So it's like you say, it's credit cards, it's healthcare data or whatever. That in itself is not sufficient today, even just those pieces. So let's take, for example, there are many businesses out there, maybe I'm a hotel, vendor, a hotel chain, right? Their definition of personally identifiable data may include like a text code I've told you to get into the door in the hotel, right? Like it's that plus who you are, like that's personally identifiable. So yeah, just saying it's just like a name and address, that was an old school way of doing it. In fact, Macy refers to it as PII. PII is like a 10-year-old term. It's really referred to as personal data these days. So within that realm, there's definitely work that needs to be done to give you the context of it, right, as you say. Then there's the whole secondary class of things around like company secrets and things. Like I could have a Word document that describes, maybe it's like your HR review, Jonathan, or like you two guys may have a critique of this podcast. Like you write a great big email exchange behind you. Like that could be sensitive. Like Mark's a complete idiot. Like let's never have him on again. And all of a sudden, like how do you figure out what that thing looks like? So there are data science techniques to do that as well. Our head of engineering is this guy called Mike Andrews who built Cortana at Microsoft. And what we have aspirations to do, like this is not coming in the product immediately, but like what we have aspirations and we're sort of working on is like, how do you do data lineage and data similarity? So like this bucket, the entire contents of this bucket are a replica of that one, or they are 95% the same as that, or this bucket's contents are actually a database drop of this RDS instance. So there's all of those types of scenarios that you've got to figure out as well. And then the other part of that is that what we're looking at doing is using ML models to say, I'm going to upload a set of my data, either a data fragment, and use Bloom filters to kind of reduce it and say, okay, this piece of data is here. Or this is a set of features. Go tell me, is this data used in other systems? And one of the reasons why we think that's really important in the long term is like when people ETL data stuff and build data warehouses, like, what is that? Oh, it's an amalgamation of like all of these other things put together. And so there's new challenges that come with the big data stuff that we got to figure out how to solve. That again is why it's not a Macy problem. It's not a individual data piece problem, right?
Yeah, and it seems like an uphill battle because at reInvent in the keynote just recently, we have new ETL features. Look how easy it is to take data from all these different sources and push it somewhere else. I mean, it must be a security headache.
That's exactly what it's done, what it's designed to do, right? I know. Yeah, totally. What's also interesting, right? It's like if you think about Avro and Parquet, right? Basically, it's become. It is the new HDFS, right? You'd never build a Hadoop cluster if it's not backed by something like that now. And so essentially what you have is, you have kind of people, data, you have Spark instances, and, EMR stuff or native Spark stuff that's basically all built on top of big data file systems. And it's just amalgamations. It's just a dumping ground to go analyze, right?
If customers out there are curious about, OpenRaven and learning more about this technology, which is really awesome, how could they get some more information about this?
OpenRaven.com. Is the simple answer. OpenRaven.com. You can get a 15-day free trial, spin it up, SaaS instance, and go play. And then, the other thing I'd say is like, we're a relatively early stage company. The thing we love is like working with advanced people who go, that's awesome, but it would be much more awesome if you did this, and like finding those real, design partners who want to work with us to make stuff scale and stuff in the long term. So like, we already think we're a better version of Macy, awesome, but like, don't think that's the end goal. Like, come partner with us and work with us on the end goal, because those are things that we love. Massive, interesting problems to go deal with.
And today it's very AWS, but I hear you have plans for the future. You want to talk about those?
Mm-hmm. GCP comes next. I'm sure Azure will come after that. But yes, absolutely.
Since you are going to multiple clouds and you have Azure and GCP on the roadmap, we like to ask all of our interview guests, how do you feel about multi-cloud? How do you define multi-cloud? What do you see as the ideal scenario for something like OpenRaven kind of playing in that multi-cloud world?
Technically, the next thing comes for us is Snowflake, actually. So talking about multi-cloud, like is that really a kind of like cloud like GCP or whatever? But we see an awful lot of people going to Snowflake. Like my personal take is I think that what's happening is that the first generation was operating systems, second generation is cloud. Now what we're seeing is data platforms emerge. And, those data platforms are going to be AWS and GCP and Azure, but it's also going to include Snowflake, and it's probably going to include, Databricks as well. And so a vast number of our customers are moving a lot of stuff into Snowflake and just kind of like using Snowflake as like a giant global S3 bucket, and then just, building stuff off of that. What we also see is like it's when you go talk to all the customers, they'll tell you like, yeah, we've got a multi-cloud strategy long term. And then when you delve into it, like they're 95% on one cloud. And the very large guys, their multi-cloud kind of story is really, it's come because they've acquired different companies, right? So it's a global game company that we got, they'll tell you 95% on GCP, and that's absolutely true. And 5% of it was an acquisition of another game studio that runs on AWS. and what I think we see generally in like customers is like people start using SNS, they start using, Kinesis, they start wiring in all these things. And they become tightly coupled to a cloud provider. Like we did, CloudFormation, like, sure, could we have done stuff with Terraform? We learned also all these lessons that Terraform wasn't context aware about what services are available in each region. So we were trying to spin things up where the service wasn't available in the region, and all of a sudden it would fail. And whereas CloudFormation was much more context aware. And so I think when you learn some of those lessons, like there's the idealism, and then there's a reality. And I think what we see is a lot of customers in the early stages try and build things that are agnostic of a particular cloud provider. As they get into it, you're kind of like, okay, I'm just going to make this work really well. And that strongly held belief kind of goes down a little bit. There are one of our, it's a big brand. I won't kind of say who it is, but they're in service provider industry, I guess. Their strategy is like build everything on Kubernetes and assume that eventually I'm just going to be able to lift and shift between providers and everything's going to be operated around Kubernetes, right? He's like, you think I'm crazy, Mark, building bare metal? It's like, you don't understand. It's like, I don't know.
Yeah, well, we are, multi-cloud is becoming a bigger deal. I mean, even Amazon has finally admitted that, hybrid is going to be a big part of their play with, ECS and EKS anywhere, which is really anywhere, including GCP or Azure, even though they didn't say that on stage. It's very clear that stuff can run anywhere. So, the era of having one cloud provider is probably kind of nearing the end. But I think it goes back to that workload story of where does the workload go? What makes sense? When
I was at Microsoft and Azure I was running MSDN, and I used to give free Azure hours, right, in the early stages. And so I was privy to kind of seeing all the early adoption stats. And I was always amazed, like the most predominant language that was deployed on Azure at the time was PHP. Like that was the first most predominant app language. And I think that tells you something, right? It's like people have one of everything. And you can't engineer things for individual things, but people will try and optimize over time and stuff.
Yeah, I actually just saw an interesting statistic on that PHP is still the #1 web application programming language out there still today, which is
global
crazy
variables. What a state of the computer science industry, right? We should all be embarrassed. And, I'll probably get some hate mail for that, but I don't.
It just means that we should all be going back to WordPress and PHP and never do anything else.
No, Justin, no.
At least it's not Perl.
At least it's not Perl. Yeah.
Set or scripts, right? Yeah.
Well, excellent. Well, it's been a pleasure talking to you, Mark. Good luck with Open Raven, and we're super excited to have you here with us on the Cloud Pod, and we'll see you in the future, I'm sure.
Yeah. Thank you very much. Thanks for having me on.
Thanks, Mark. Visit thecloudpod.net to subscribe to the show, join our Slack channel, or sign up for our weekly newsletter. You can also find information on reaching our audience through a CloudPod sponsorship opportunity. A big thank you to today's guest, and thank you for listening.
Visit openraven.com/thecloudpod to learn more and start a free trial to discover, classify, monitor, and protect the data you have in the cloud.